Alright, grade 10s. I know you probably got through the Pythagoras lesson with great difficulty, as so many of you realize that it's the same lesson from grade 9 when you learnt Pythagoras, and I was actually way too tired to do a new one for grade 10, so I actually just stole the lesson from the grade 9 one. And I apologize for that, but this is the last one here of the day and I'm spent. So, let's do some solving triangles. Solving right triangles. Now this is exactly the same stuff you did in grade 9. There's a couple more questions and a little bit more to it, and I expect more of you. But all in all, it's the same skills, okay? So if we do an example, we'll just get right into it. Solve given angle C equals 90 degrees, always, okay? So given, let's go with A equals 7, and we'll say side C equals 14. Okay, so if we can think back to grade 9, I know so many of us have a hard time thinking that far back, but the first thing I always want you to do is draw out your triangle. So there's your triangle. Label your triangle correctly, A, B, C. And it's nice and easy in grade 9 and 10 because right now we're only dealing with A, B, and C. But you guys understand that it wouldn't matter if I said P, Q, and R, and R was the 90-degree angle. It wouldn't matter where A and B went. But your side A matters. Side A equals 7. And I know that that's side A because it's opposite the angle A. And same with side C. I know that it's right here and equal to 14 because side C is opposite angle C. So now I can label the other sides, but I don't know them. So I'll just put a question mark there. And we don't know angle A or angle B. So we set up our solution square. That's the second thing. So first thing, draw and label your triangle. Put everything on there that you know. Any information, any names, whatever you know. Then your solution square. So we need to find side B. We need to find angle A. And we need to find angle B. Okay? Let's make sure our calculators are in degree mode because you're going to need to know how to use them. Okay? So, I'll try and refer to regular and backwards for those of us so that you can maybe figure out what we're doing here. Okay. Here's my hint. You can always start, well, you start with one of two things. You either start with the Pythagoras theorem or the 180-degree rule. Okay? You always start with one or the other. In this case, I've got two sides, so I know I can use Pythagoras. I can't do the 180 rule because I only know 90 degree, nothing else. I need to know at least two angles to do the 180 rule. Okay? So we're going to start with Pythagoras in this way. But knowing that we start with Pythagoras, that means we're going to end with the 180 rule because it always flip-flops. And in between, we're going to do a trig ratio. That's how easy it is. So you start with Pythagoras, do a trig ratio, end with 180. If we start with the 180 rule, we do a trig ratio and end with Pythagoras. Let's get to it. C squared equals A squared plus B squared. C is the only one that matters, and that's always your hypotenuse, right? So if I look at my triangle, the hypotenuse is always across from the right angle. So I'm going to plug C in. That's 14 squared equals 7 squared plus B squared. Okay, when we go and simplify this, 196 equals 49 plus B squared. Yes, we all know to subtract the 49 over. That'll cancel. 196 subtract 49 is 147 equals B squared. Okay, so square root of 147 should be 12.1. So B equals 12.1. 1 decimal's lots. So I'm going to put that on my picture, 12.1, as well in my solution square. Okay? So 12.1, all over the place here. Now, like I said, we started with Pythagoras' theorem. Now we have to go to a trig ratio. We have to, in order to go any further. Well, we have to do a trig ratio to find one of the two angles. Now, ask yourself, does it matter which angle I go and find, whether it's A or B? My answer is going to be no. It doesn't matter, whichever you want to pick. Okay? If I decide to go with A, which I'm going to do, okay? So side or angle A here. There's angle A. I've got to name my sides from that angle. If that's the angle I'm using, I got to name my sides from that angle. So the opposite side from angle A is side A. The adjacent side is side B because it's beside the angle A. And your hypotenuse we already named because we needed to know that for the Pythagoras theorem. No big deal. But now, in order to find an unknown angle, I have to use a trig ratio. Well, the trig ratio of sine theta, okay, and we'll review these, but in this case it's going to be sine of A is equal to the opposite over the hypotenuse. So when I fill this in, I'm going to substitute my values in. The sine of A, we don't know what A is, that's what we're trying to find, is equal to the opposite side, which was 7, over the hypotenuse, which is 14. 14. That doesn't come out real clear. Okay. So now, the sine of A equals 0.5. And when I second function that, 0.5 second function sine, I get 30. So second function it. Angle A should equal 30 degrees. Okay, so I'm going to place that on my triangle as well in my solution square. Just like so. Okay, so again, it doesn't matter which angle you pick. If we chose to do B and we named the sides, yeah, the adjacent and opposite would be on different sides, but we would still do it correctly and we'd get angle B to be 60 degrees. But now that we did angle A, we're going to use 180 rule to find angle B. And we'll find out that it's 60 degrees anyways. So angle B equals 180 minus 90, because we know 90. And we also know now that A is 30 degrees. So angle B, if we do that correctly, we end up with 60 degrees. Okay? So 60 degrees. And because I'm not there, and I've got nobody around me, and I'm talking to myself, I kind of forget things like making assumptions that you guys all remember the trig ratios, and I don't realize it until I get through that example that you guys might need these things again. Trig ratios. Okay? So the sine of, I'll just call it theta, because that just means any angle, is the opposite side over the hypotenuse side. The cos of theta is the adjacent side over the hypotenuse side. And the tan of theta is opposite over adjacent. Okay? So, again, you get all those. Anyways, you don't have to memorize them or anything like that, but you do need to know them. Okay? So, we'll get to the next example here. Well, let's go like this. Given we know angle C is equal to 90 degrees. No big deal. Let's go with side B equals 9 and angle A equals 42 degrees. Let's do that. So, step 1, draw your triangle. So, angle A, angle B, angle C. Okay? Put my sides on. Little a, opposite angle A, little b, opposite angle B, and little c, opposite, excuse me, angle C. From there, I'm going to put all the information I know. Little b is 9. We also know angle A is 42 degrees. Okay. We don't know little a, we don't know little c, and we don't know angle B. Pretty easy though from here. We're going to do our solution square. A equals, C equals, and angle B equals. Alrighty. So, remember, start steps. 1. Start with Pythagoras or 180 degree rule, right? Because all the angles of a triangle add up to 180. So one or the other, depending on what you have. Step 2, use a trig ratio. Now, there's more to that. Of course, you have to use pick an angle and name your sides from that angle and figure out which trig ratio and all that stuff. But use a trig ratio and find another piece of information. Okay, so one other piece of information. Step 3. Finish with Pythagoras or 180 degree rule, whichever you did not use in step 1. Oh, that's kind of gibberish there. Whichever one you did not use in step 1. So finish with Pythagoras or 180 rule, whichever you did not use in step 1. Okay, I know you can't read that, but my pen's starting to lose power. So here we go. 180 degree rule we have to start on this. Because I don't have two sides, I only have b is equal to 9. Okay, I only have b is equal to 9. So I can't use Pythagoras, so I have to use 180 rule. And yes, I know two angles. Angle 90 degrees and angle 42. So, here we go. Angle B equals 180 minus 90 minus 42. So angle B is equal to 48 degrees. Okay, that's a no-brainer. 48 degrees. So put that in your solution square. 48 degrees. Okay, so step 1, we did. Started with 180. Use a trig ratio. Now, here's the question that everybody always asks is, how do you know which angle to start with? Well, all I can say is, it does not ever matter, except you can never use angle C. You can never use angle C, ever. Okay? That's a no-no. The only thing angle C is ever used for is to finding the hypotenuse, because the hypotenuse is always across from the 90 degree rule, or 90 degree angle. So never use angle C. So pick A or B. It doesn't matter. I personally, in this case, I would have picked A to use because it was given to us. But if you want to use B, go ahead. In fact, I'm going to use B to show you that it doesn't matter. So from angle B, because I'm going to use angle B, I have to name my sides from angle B. So here I go. I'm going to use red here. So from angle B, I'm going to name this one my opposite. Side A is right beside it, so I'm going to call it my adjacent side. And we've already named the hypotenuse again. So here we go, one more time. What side does it matter? What side should I pick? Well, it doesn't matter. Okay? If you just want to find A, go ahead, find A. If you want to find C, go ahead, find C. But you have to use side B because you know it. So no matter what you do out of those three trig ratios, you have to use one of the three that has the opposite side in it. So in this case, I'm going to go and find side, let's see, A or C, A or C. Let's find side A. So opposite and the adjacent. What trig ratio is that? If you said 10, you were right. So the tan of B, I have to use B. That's what we named our sides from. So the tan of B is opposite over the adjacent. So the tan of 48 degrees. The big mistake some people do is they'll put tan A in there after they've named the sides from B. Well, whatever angle you start naming things from, that's the angle you have to use. So the tan of 48 degrees is 9 divided by little a. Okay? Well, our unknown's in the bottom, so I'm going to multiply that up and across, and I'm going to bring tan 48 down. I'm going to divide it out. And some of you will remember I call that riding the escalator because you got one going up, one going down. So little a is equal to 9 divided by the tan of 48 degrees. So little a is equal to, and make sure your calculator is in degree mode. On the regular calculators, I'm going to go 9 divided by 48, hit my tan button, then equals. So I get little a equals 8.1. So I can write that down, 8.1, and in my solution square, 8.1. On a backwards calculator, you would actually press 9 divided by tan 48, then equals. Okay, so a little bit different, but not all that difficult. Okay, so now if you notice on your triangle, we now have, or know, two sides. We have side A and side B. So we can go and use those now to find side C using Pythagoras. So Pythagoras theorem, c squared equals a squared plus b squared. Hypotenuse always goes into C. Okay, holy moly, my pen is dying here. I'm going to switch over to red. So c squared equals 8.1 squared plus 9 squared. So c squared equals whatever 8.1 squared is. 8.1 squared. 65.61, but I'm not even going to really show that. Plus 9 squared is 81. So that equals 146.61. I square root that now, and I should get side C equals 12.1. And it should always be your longest side. If you don't get that to be your longest side, you've done something wrong. So side C we get to be 12.1. Okay? So, biggest thing is knowing or figuring out what trig ratio to use. As well, this little step, another one of those assumptions I kind of made that you guys would either know or be able to work out in your head. If your unknown's up top, it's real easy because then you just shoot the number up top and you end up multiplying. But it's when your unknown's in the bottom that you have to flip them around like we did. Okay? I hope that's enough to get you through assignment A, B, and C and started on D. So, draw your triangle, label it, put all the information on it, okay? Then follow the steps. Okay, Pythagoras 180 rule, then work out the trig ratios, okay? And I know that you've got lots of help with the teachers around you.